Yeah.
it was one or two
Huh.
steps that I did not understand.
So that is not that much useful. Like that is a one kind of proof, and it is not like it is a tough. If you will use that definition of derivative, that's all. It will be arrived after like
Your voice
if
is
you want to find the derivative at a.
voice is lagging and
So
breaking off.
DDF, my voice is no like concept or what you said, right? I didn't listen
So,
clearly.
he had written that f into g dash a is equal to f dash a g of a plus f of a g dash at a. And how he arrived at limit h approaches to 0. F of a plus h into g of a plus h minus f of a into ga. It was just in the beginning of the. So limit
Yeah. So
h.
to get this derivative, you uh, yeah. So I'm saying to get this derivative, just use the formula.
Your voice is lagging too much,
That
sir.
definition of the
Sir, we can't hear you, sir.
I can't hear you, sir. Your voice is breaking a
derivative
lot and it is
at
lagging.
point. Okay, let me see that where is that lecture?
Sir, your voice is breaking, sir.
Sir, it was just in the beginning of the lecture. The product rule.
Just 1 minute. Let me.
Computing derivatives and L'Hopital's rule.
Hi, Hal, am I audible right now?
Yes, sir.
Now you're audible.
Yes, sir.
Hello.
Yes, sir.
Yes, sir, you are audible.
Hello. Am I audible?
You audible?
Yes, sir.
Yes, sir. You
Yes,
are.
yes, sir.
Yes.
Yeah, okay. I don't know.
Your voice is breaking.
Yeah, okay. So just 1 minute. Let me share my screen.
Has the class started?
Sir's connection got lost, I think.
Okay.
Is sir not available? Hello.
Yeah, I think so.
We got two network issues.
Oh, okay.
Hi, am I audible?
Yes, sir.
Yeah,
Okay, just 1 minute.
Yes, sir, you are audible. Now it's
Okay.
perfect.
Okay. Just 1 minute. I'm waiting. Yeah, hi, now maybe it will go perfectly. So let me share my screen. Yeah, so I was discussing about this product rule of derivative.
Yes, sir. Yes, sir. Yes, sir.
Yeah, so see, don't worry with see, if you use this definition for this product rule, like they try to get the limit on or in which lecture this product rule sir have done?
It was 8.3, sir.
Yeah, so see, see
Sir,
mostly,
before this, इससे पहले sir,
yeah,
थोड़ा सा.
yeah. Yeah, so yeah, in this video
Yes,
there
yes,
is
sir. The
also,
professor had written in that black pen. I don't understand it.
yeah, this portion, yeah, I'm getting that.
Yes, yes, yes.
So yeah, so just use of this definite like limit form. So if you do like writing to be the limit, like doing just 1 minute, let me guess that
Sir, I don't know. I don't understand the step he is just writing now.
huh. Yeah, there is you have to add a plus h a minus something. Yeah, sir is writing this see, sir have did this next step in this. Now you have to make it separate here. Like here is sir have took common and did this here. Now here sir have took common for GA and did this one. Now make it separate limit and do that. Are
Sir,
you getting? No.
Can you explain it? No, sir, I'm not getting. Can you
Yeah,
explain it in little detail? Yes.
yeah, that is, this can be a plus h GA plus h minus this is
Sir, is that
this
derivation
is,
necessary? So we have
no,
to
it is
memorize
not
that.
necessary. I don't know why it's why he is asking this. This is not necessary here. This is just a calculation kind of like doing to be here the,
Oh, okay, sir. If we can leave it for a moment now, then it's okay.
see, now you what you need to do, like you have to add G plus H, and also you have to separate here subtract, or here is add and adding here and making it subtraction G, and also GA you can add, and subtraction. Now FA and GA. Now take common as needed and divide by H.
Okay,
Right? There sir have did that. That is sir is doing here. Adding and subtracting something. Okay. And this proof is not needed. Only just formula is enough. That's all. Don't worry. Here is sir is adding. If you like multiply, you will get that what's happening. Like he made quickly here. Just multiply each one by one, and not GA. Like here is adding and subtracting GA and FA. Multiply added with G A plus H into FA minus A plus H and FA. Now here is FA and GA. Now take common as needed. Like here you can take here G plus H, GA plus H common, then it will remain F A plus H, and you have to make it here minus, here plus.
Okay.
And here for this one, take FA common, it will be GA plus H minus GA. Getting no? What I am doing here?
Yes, yes.
Now apply this is H here. Okay, now it is H. It is when you did here for H, so it will be H equals to 0. Now make it separate here, limit. It will be G plus G A plus H, F A plus H minus F A upon H, limit H goes to 0 plus F A G A plus H minus G A, limit H goes to 0 upon H. Now this portion is F prime and this is GA, derivative of F. Okay. And this is again FA, and this whole is, this portion is G prime A. Clear? Am I audible?
Yes, I got it.
Yes, sir.
Yeah, so let me go with the raised hand, because I am looking. Jivitesh have asked, he have raised his hand. You can ask, Jivitesh.
Yes, sir. So my doubt was in activity 8.4.
Which question number?
So 7 and 8. So can you just explain what is linear approximation using any of the example, any of the sum, either 7 or 8?
Okay. So see, the motivation for linear approximation is like you. I'm just saying the motivation, and then I will write the formula. That's all. For the like formula is enough to writing. There is not any behind like intrinsic kind of meaning. The motivation, if you are suppose this is a curve, so and suppose you don't have something like function, you don't have this function, like what is the expression for this function, but you have some derivatives at some point. Like it is given that suppose f a is equal to some number, suppose alpha f a1 a2 is alpha, this is alpha 2, some number prime is given. So what you will do, you don't have this expression, so but what is the graph of the function? So you can approximate each point with some line like this, like this, like this, like this. So approximately you will get the like if you remove this one, so roughly you will get how the graph of the function is going by linearly. That's the meaning of what is the linear approximation. And the formula for linear approximation is this is at writing to be let's say L. This is notation is LFX, and anyone can tell what is the formula? Any can unmute yourself and
So
can tell
f
what
of
is
a
FA
plus f dash a
F prime A.
x
Okay.
minus a multiplied by x minus a.
Yeah. This is the formula. This is the equation of a line. See that this the degree of x or degree of this LFX is 1. That is, it says that this represent a line, and so that's the saying to be linear approximation, approximating by some lines or more lines, infinitely many lines. Getting no?
Yes, sir. So can you just help how to apply in a example?
Yeah. So now let's say let's see that in this question itself we have fx is equal to root over x. So here is directly expression is given, but behind the meaning of this linear approximation is approximating the graph of the function by lines. Now you need to find f prime. So f prime means derivative, I am saying. So it will be 1 by 2 x to the power 1 by 2 minus 1. This is writing to be like this. Now it is 1 by 2 and x to the power 1 by 2 here in it will go in denominator. Now this is 2 root x. Now what will be, it's asking at 4. Okay, so f prime 4 will be 1 upon 2 root 4. It will be 4. Now use the formula. So you have fa means f4 plus f prime 4 x minus 4. So f4 will be 2 plus f prime is you got 1 by 4. Maybe if I'm doing mistake numerically, please correct me. This will be x by 4 minus 1. Now this is x by 4 plus 1. So this is the linear approximation of f, which is root over x. Now asking find the value, approximate value of 4.4. That means just substitute here 4.4. So it will give the approximate value of the function. Like, see, this lines are approximating the graph. That's the mean asking for approximate value. Am I
Could
audible?
you just show which question number it is? Which
Yeah.
activity question?
This is 8.4, question number 7 or 8. 7.
Thank you.
So is it clear what I am saying?
Yes, sir. Got
Julius?
it.
Yes, sir.
Okay, so
Got it, sir. Got it.
so Srutika is now she have raised. Yeah.
Hello, sir.
Yeah.
I have doubt in week 8, activity 1, question number 1, 4, and 5.
Activity 1, question number 4 and 5.
1, 4, and 5.
Okay. Okay, so here what's doubt here for you?
Sir, in question number 1, I get the two options, that is where the left
Am I
limit and the
audible?
right limit. Yes, sir. You are audible. Hello.
Hello,
we
am I
can hear
audible?
we can hear you, but not sir, I think.
Okay.
Is it okay if you ask for a small summary type of discussion for 15 minutes for the week 8?
Okay. Okay.
Sir is not able to hear. Better you ask in chat.
Yeah.
Your voice is breaking.
I think sir got lost the connection.
Hello, am I audible?
Hello.
Hello. Audible.
Your voice is breaking, sir. Maybe my internet.
My is
Sir,
it
your
now
voice
clear?
is breaking. Now it's clear.
Now it's clear.
Okay, so let's start. Let me share my screen again. So what's doubt here? Shruti?
Yeah. So in question 1, I wanted to know why option 1 and 3 are not right.
Okay, so what's okay, so how you are am I audible?
Yes, sir.
Am I audible?
Yes, sir, you're audible.
So okay. So what do you think about option 1 from your side? I'm asking. why this should true?
Sir, because if option 2 and 4 are right, like if left limit is present, which gives us L as value, then it must be like f is defined at A. So
Okay, I think an example. This is limit extending to A, x square minus A, x minus A. I am writing a function like x square minus A, x minus A. So this function is defined at A. If you want to write the domain of this function, what will be the domain for this function?
Sir, are both 2 and 4 options same?
Sorry?
So both the 2 and 4 options are the same? Not.
No. She is asking, no, I for this question you are asking.
Yeah, sir. For this question, in the question, if you
Question
see,
means no, the first option is saying so true. So I am giving an example and asking, is this function is defined A? No, true is or whatever your answer.
so I'm telling is option
Is this defined? No, right? At A, no, I'm just asking. Suppose this is a function. Is this function is A or no? This is my question.
this is not defined because the denominator will be 0 then.
Okay, so I'm writing like x minus A now. Sorry, x tends to A, x square minus A, and at A this function.
Yeah, this function is not defined at A.
It is still limit this can be done and the limit 2A. So what's happening here? Limit exists.
So your voice is breaking, sir.
Your voice is still breaking. No continuity in voice. We got lost towards this.
And your screen is also lagging for us.
Yes. Continuity is not there.
Okay, just 1 minute. Okay, just 1 minute.
So one small suggestion, if you can log in through one device for sharing the screen and use your mobile phone for audio, so that would work in case if it is possible at your end.
No, see the problem is internet issue is there is no issue only the internet. So connect with my mobile. That's the only fix.
The break is in voice.
Your voice is gone, sir. Yes.
Is it now clear? Is it clear? I hope it's better now. Is it clear now?
Yes, sir, it's better.
Yeah, sir.
Yeah. Okay, so let's continue with the discussion. So what's happening here? The function, this function is not defined at A, but still limit is exist, right?
So we can't see the screen.
Okay, okay, just 1 minute. Okay, here for this function, the function is defined like this: x square minus A upon x minus A, and asking for limit at A. So limit is exist and which is 2A, but the function is not defined here.
Sir, it is x square minus A square.
Yeah, let me.
There is no content given over there.
Yeah, please mute. Am I audible?
Yes, sir.
Okay. So and my screen is, I hope my screen is
Yes,
visible
sir.
also.
Yes, sir.
So what you are interpreting here? What you are interpreting?
Okay, so I got your point. Like the limit is possible, but for the function is still not possible.
Function is not defined at that point, right?
Yes, sir. Yes, sir.
As here is happening.
I got your point. Thank you.
Sir, is this A or 9?
Okay.
Is this
Yeah.
A or 9? It's
This is
A.
This is A, or you can assume 9 also, but no matter. This is A.
So
So
the top one should be, I suppose, x squared minus a squared in order to factorize.
yeah. So okay. So
This
I
should
maybe
be
I
a
made a
squared.
mistake. That's yeah. Okay.
Yeah, then it's fine.
Sorry. Yeah. This is will be normally. Okay. Yeah. I made here. Okay. So now what about the option 4? Option 4 is still you are saying to be, is it can
No,
possible?
no, it's not possible now. Yeah.
But sir, if in the in denominator x plus a would be there.
In numerator, this is in numerator x plus a will be, that's the saying to be limit. That's the in denominator it's cancelling, but in numerator it's x plus is available. So that's why the limit is 2a.
I'm saying if we take in denominator x plus a in spite of x minus a.
Yeah, still the limit will exist, right? It will cancel out and it will be x minus a. It will give 0 limit. So limit will be 0.
But at this time, function will be continuous at
Yeah,
a.
for this function, at this time the function is defined. But yeah, you have now, if you saying to be, I am saying at x goes to minus a, in this situation the same situation will arise again. Like it is not defined at minus a, but limit is exist again, which is 0. Okay.
Like my question is that there is no as such function defined in the question. So we assume such type of situation.
Yeah, you have to assume. Yeah, then you can neglect the option. Yeah.
But if we assume the question is giving limit x tends to a and in denominator x plus a, then that option is right now in that situation, if I assume in that way.
But you want to be like, there are some option, there are some situations. See, this is a general case is written, right? And asking what could be possible. There are some situation, like in which situation this will always true. Like if this is given, then it will always true. In which, in this 5 option, which will always true. It will not affect on the how the function is defined. Like here, I have changed the function. It is options are like some option are wrong, but for this question some option may be right also. But for if I will change this function, the option will change. But for which situation, for which function, like for all function, which option will always true? You have to choose appropriate that option. Appropriately.
This option is always true for every situation, right? This we have to choose. Okay.
Yeah. It will not affected by that function, changing by function. Okay. So let me go with the again. Rishabh is had. Rishabh?
Yeah, hello. Audible, sir?
Yeah, you are audible.
Yeah.
So what's doubt?
So my doubt is in practice assignment 8.
Which question number?
Question number 6. I got the value for n, but I got the value for m. Question number 6.
This one. Okay.
Yeah, this one, sir. I don't know how for the answer. I checked the solution also, but I couldn't get it.
So See, as here is saying, if the function f and gt denoting the profit of company A and B continuous at 3. So both function f and g are continuous at 3. So use this just definition how you are getting m. Similarly, you will get a relation in m and n. And then if you have already got the answer of m, then you can get n also. Or separately also, like there is no relation. Okay, there is no relation is
No
m and
relation,
n.
sir. No. Yeah, no relation, sir. For n, we have to solve first
Separately, yeah.
equation.
So again, as you got for m, use the same definition. Like it is continuous at 3. So use definition, algebraic definition of continuity. The definition is limit value at a means at 3, it will equal to the function value at 3. No?
Yes, sir.
Are you using this definition? No. So
Yeah, yes.
when you are using, you will get some. Okay.
Yeah,
Continue.
I'm getting overall equation equals to 3. Yeah, I'm getting that point, sir.
Mm-hmm. So
I'm getting that. I use L'Hopital's rule. Then I got it, but I whole the equation got equals to n, and then equals to 3. How it got equals to n? That's not. I'm getting that point.
Okay, where is solution? Practice solution is there somewhere?
Yes, the resources from instructor. Top.
Let's go with the whatever solution is written.
Yeah, just yes, sir.
Then it will be more clear. Question number 6. Okay, here is
down, sir. Down. Yeah, 8 number.
Okay, so
yes, sir, that one. Using L'Hopital's rule, we get how we get equals to n, that point. Yeah, that line. Yes, sir.
So using L hospital rule, L'Hopital, whatever you will say. So
yeah, I got. Yes, sir.
So just derivate it. So it will be this one, right?
Yeah,
Derivative of numerator and derivative of denominator. Denominator will be 1 and numerator will be n will be go to here and t.
Oh yeah, I got it, sir. I got it. Then put t equals to 3. Yeah, I got it.
Okay.
Yeah, I got it.
Okay, let me see. Now Shrutika is again based here or previously.
Yes, sir. I had a doubt in question number 4 also, activity 1.
Okay. So again, what's out here?
Sir, I'm not able to understand this.
Okay, so here is just asking use the definition of continuity, like algebraic definition. If you will use that, it will give a relation in between. Like it is saying to be continuous. All option are asking for continuity. Like here is first option is always continuous, or it will continuous when a, b, or 0. So okay, so are you using the definition? No. What is
Yes.
definition for continuity?
So one is that every point should be differentiable at that point. I mean, then it is continuous.
No, just simply saying in the limit form, like
there should be no breaks. There shouldn't be no
definition
step.
means saying to be algebraic definition. Let's say I'm saying definition to be in the form of limit form. So a function is said to be continuous at point A when limit value at A will be the exact value of function value at a. This is going to be the definition of limit definition, you can say. Limit
Okay, sir.
definition. Now if you use this one, like finding the limit, now if you want to evaluate the limit at a, you have to find the left limit or left hand limit, which is saying to be h tends to 0 of a minus h, and right limit is limit h tending to 0 f a plus h, and both should equal to the value of function at a. If you use this one for separately for this one and this one, you will get the answer. You will get the relation between a and b, and you can decide when it will be, when this will possible.
Okay,
The
sir.
limit value should be when it will happen. The limit value at a will equal to the function value. Okay. So Rahul is.
So question number 5 also, sir. Same activity, question number 5 also.
Okay. This one here.
Yeah, yes, sir. I got the sir option 3rd and 4th. I got it. For the option 1st and 2nd, I'm confused.
Okay, again, there exists a continuous function in this interval, close interval 1 to 5 and 1 to 7, such that function value at 3 will be pi.
Can you please explain option 4 also here?
Yeah, sure. Yeah, so like this is like which of the following options are true? They are just asking for, is there a function which this will happen? There is a function in this interval, domain will be closed interval 1 to 5 and range will 1 to 7, and the function will be exactly at 3 pi. Is there a function exist or not? So how you will know that is there any function? Like function is like so many functions are there, but how I will choose such function, right?
Yes, sir.
So let me tell you, I am defining a function like this, as domain is given and this is range is saying to be, and this function, let me say f of x is equal to pi. So is this function is valid for this option? As domain is says, range is also as here, and the function is what will be at 3 value? It will be pi, right? Because this is a constant function.
Oh, yes.
And constant function is always continuous.
Always continue. Yes, sir. Yes, sir.
So, and asking this option, there exists a continuous function. So yeah, we got a function like this. There are other function also, like writing like this. 3 pi or maybe pi x upon 3. This is a linear function.
Yes, sir.
And still it will give at 3 it will be pi. There are so many function which is continuous. So if we change the option itself, there exist infinitely many function going to be like at 3 it will be pi. Still it can possibility you can get infinitely many function.
Yes,
right,
sir,
like
yes.
this. If you divide with 3 and something, maybe if you will ask, you can divide n will be some number.
Yeah, even pi x square by 9 could be the function.
Yeah. So there exists, you are able to get a function which is satisfying this condition.
Yeah, got it, sir. Thank you, sir.
Yeah. And for fourth option, there exists a non-constant function from real to real number to real, which is bounded. So again,
Sir, can an exponential function be fulfilling this third one? The exponential function.
So somebody's asked fourth or third? Fourth option.
Could you
Okay.
also explain third also? Someone has
Okay.
asked for fourth, but could you also explain third? Can exponential function be one which would satisfy third option?
So exponential function is bounded or not?
It has. It
Is
can't.
that
Yeah, I think
the
it is.
graph of exponential will be any a power x? A should, let's say a is greater than 1. So what is the graph? This will be approximately maybe rough diagram of exponential. So is this bounded or not?
Sir, I think I don't have clarity on what is bounded. Bounded means that its domain is bounded, or its range that it can take of y values is bounded. I'm a bit confused in that.
So bounded means see, domain is like for bounded definition there is no mean of domain, but range is saying to be bounded. Like bounded
this
means
case,
you
it would
have
be, yeah.
like this condition.
Yeah, so that means it can only take certain finite values of fx.
In some two real number, the all function value will be in between.
Like
So
sin
I would
x is
say
bounded
this is
function.
bounded.
This is the mean of the bounded. Yeah,
Then
sin x is bounded.
Between -1 and 1.
Okay, but even exponential would be bounded at least on one end, or we have to have both ends bounded.
Bounded means
both ends
sides.
bounded.
Both side have endpoint. Yeah.
Okay.
If one side is like this, then you can say left side bounded.
Okay.
Okay. If suppose like this is, so left side is bounded, or like this, so right side means saying to be lower bounded and upper bound. That is called lower
So
bound
this
and
one
upper
is
bound.
lower bounded.
So this one is lower
Exponential.
bound and this one is upper bound. If such case is happening, this is called lower bound. If this is happening, this is called upper bound.
So
If
we could
both
say
is happening, then
exponential
you can
is.
say bounded.
So exponential is lower bounded, right?
Yeah. Exponential is lower bounded. Its
And
range is from
sin x is bounded, fully bounded.
yes, sin x is fully bounded.
Similarly, cos x.
Yeah.
Okay, thank you, sir.
So let's move on the fourth option. There exists an unbounded continuous function from this interval open 2 to close 3 to r. You can get some unbounded function. Can you tell me what now? You can tell what is. Can you give me unbounded and continuous function? The situation is unbounded, and the second condition is continuity should be
line function.
So line, yeah. So still line can be bound, right?
Why?
Let's say this is linear function. Line to be saying to be linear.
Yeah.
Now this says like this. So maximum you can give it, like if you substitute here for any just 1 minute. This can be bounded. Let's say this f3 will be 2. It will be 3a plus b. It's depend on the coefficient of a, but still it can be bounded. And f2 will be f2a plus b. You are able to get some value and you can approximate these values and make it bounded. But there are some unbounded function also. Can you tell different? Like you can see this can be, if you are, let's say this is 2 here, and this is 3 here. This is a linear function. Yeah, hi. Am I audible right now?
Yes, sir.
Yeah.
Yes.
Yeah. So let's continue with the discussion. So
Yes, sir.
asking for an unbounded function. Let me share now. I am able to share my screen. So asking for unbounded. So what do you think for, like, there exist if you able to show a single function which is unbounded, that's enough. So what do you think about this function itself? 1 upon x minus 3. What do you think about this function? Think like this function is defined, this one, this is open to R. Okay, so let me domain is just 1 minute. Let me check once. Am I audible?
Yes, yes.
Yes, sir.
But for 3, it is undefined, right?
Yeah, for 3, this is undefined. So we want to a defined function. So yeah, we have to now find some different. Let's find some different function which is unbounded. Let's do yeah, this is for 3, it is undefined, so it will not come in domain. This is to be exponential. Still it will come to undefined case. Okay, so let's say this is x minus 2. So what do you think about this function? Now it is clear. Now it is well defined, right? It is 2 is not included in this. So as here, this is open side 2 and closed side is 3. So what do you think about this function? Is this bounded? Am I audible?
Yes, yes, you are audible. You are audible.
So what do you
Yes,
think
sir.
about this function? Is this bounded?
Bounded. No, because
Because when you go to very close, it will be very close to 0, and it will give a bigger number, right?
Correct.
Very bigger number.
Correct.
So again, it is an
Plus
open.
infinity will give a very small number, and minus infinity also will give small number.
So yeah, so when you substitute here, like you are going to very close to 0,
correct,
it will give a very big number.
Big number, correct, big number.
So always it is the case like very close to 2. If suppose this is now if you want to prove is this bounded or not, suppose this is bounded. Let's say this is M, and left side is bounded because value is always greater than 0, because in this domain, like lower bound you can get, but upper bound is the difficulty because you are going to 2 from right side. So lower bound is there, but upper bound is the problem. Let's say this is CM is an upper bound. Now you can reach a contradict that this function is not bounded. Or simply if you see the graph also, it will give asymptote at 2. It will be an asymptote at 2, right? It will be like this. So always give a bigger number. It is not saying to be a bounded, right? Are you getting what I'm saying?
Yes.
So this function now is what function continues now to the unbounded function in this interval. Is this function is continuous or not? So if you check that, yeah, it is continuous because at each point you can get the value, limit value exactly at the function value at any point. let's say this is saying to be x goes to a. Let's say I'm saying a belongs to this interval. So and fx equal to limit x tending to x tending to a. This will be 1 upon x minus 2, and this is a minus 2. This the limit value will be exactly substituting a here. This is a here. A minus 2 will be. Now a belongs to this interval. Always you will get a non-zero value which says this is exist. A minus 2 will be a non-zero value, and you will get always a finite limit. So limit is exist, and exactly as the function value at a. That means this function is continuous, right? What I'm saying, are you getting all of you or not?
Yes, yes.
Yes, sir. I have a question. What does it mean when they're saying that an unbounded a continuous function from 2, 3 to r? What does it mean 2, 3 to r?
This is a interval open 2 to close 3
To
on
r.
real line.
So r could be from negative infinity to positive infinity, right?
Yeah. R could be negative, positive, any real number.
So that means apart from this 2, 3, anywhere to the left and anywhere to the right. I don't understand this definition of the domain.
See, this is a range. This is not not range, codomain. This is codomain. The function is defined from interval open 2 to close 3 to r. This is codomain. So for this this function, it can some part be remain, like it will always give positive as we defined here. But but some negative number is there. So it's codomain.
Okay, so R is the codomain and 2, 3 would be the
Domain of the
restricted part of the domain that we are looking at, whether it's continuous or not. So in such an example, could we take the log function also, because that would be unbounded and I think continuous within this range.
Log x can be like increasing function, right? This is the log. And
yes, so isn't it unbounded?
No, for this, see, this interval is
2, 3.
This interval is bounded, like, and log is increasing. So log 3 will be log here. If you substitute here, then log function is log 3 will be the maximum because it is increasing, and log 2 will be minimum.
Yes.
Right.
Yes.
So it is bounded. It's going to be a bounded function log for this interval. Only this
for the
interval
it's
not for
bounded.
Okay. For interval, in this interval it is bounded, but if you are assuming whole R, then it is not bounded.
Okay.
If you won't mind, can you please give few more examples for option 3? Few more functions for option 3.
Okay. Just, okay. Non-constant, continuous, and bounded. Okay, so what we give here, non-constant and bounded. Sin is also okay. What we give the first example? Okay, non-constant continuous from R to R, which is bounded. So different is sin, as we discussed. We are discussing sin as also non-constant and bounded. You can like saying to be sin x, cos x, tan x is unbounded. Okay, so and different is differently.
Okay. All polynomials are unbounded, right?
Sorry.
All polynomial functions, polynomials.
All polynomials are unbounded over R. Yeah,
yes.
Domain if you are taking R. Yeah. Okay.
Okay, thank you.
Yeah. So let me see. Divya have raised her hand. Divya, you can ask your doubt. Divya. And first thing, I am very sorry for this internet issue. Maybe now it will be continue. I don't know what's happening for today.
Sir, regarding derivative exist or not exist, sir, for exponential function?
Derivative is exist, right? You can see that formula I sir have also written. What will be the derivative? I don't know you are going through this and solve assignments. Very good. Maybe you can see all key points and whatever formulas of like derivative. Solve it. So
Sir,
what
may
will be
I
the
ask?
derivative of
Oh.
exponential? Yeah, you can ask. We are just saying to be the derivative of exponential is a time, like you know that composition of function, like derivative of composition. First derivate this and then get this one. So it will be a to the power x. Now it derivative of this portion is a. So derivative of exponential is a e to the power x. And it is continuous also. You can see with the graph, there is no any sharp corner or anything. It is continuously, there is no break in the graph, right? Okay, now you can ask.
Sir,
Yeah,
activity
Sam.
question. Sir, may I? I'm
Yeah,
sorry.
yeah, sure. You can continue.
Sir, in the same 8.1, I am not able to do question number 7.
7, just now I discussed. Okay, question number 7. Okay. Yeah, this one. Again, continuous. You have, if you use continuous definition, limit form of continuity. Limit form definition, like function is continuous as limit of the function at a exactly the value of the function at a. And this you can in left and right form, like left limit and right limit, and both should equal to exactly the value of the function. Both should equal to this one. And if you try to get those two value, you will get a relation, or you will get value in between a plus b, or you will get a relation which give the value a plus b. Are you using this one to get the value of a plus b, this definition?
Sir, I know how to find left hand limit and right hand limit, but I just don't understand within those range, those formulas, and how to put them in, how to find in such kind of a function.
Okay. So I am writing, you will tell, and maybe while discussing it, it will be clear. So like what will be the left limit now, and what is the definition for left limit? Limit h tending to 0, f a minus h. What will be this one?
Sorry?
Limit h tending to 0.
Yes.
Sorry?
Sorry, what are you asking, sir?
No, I am asking what will be the definition for left limit? This one, right? Limit h tending to 0, f a plus h at a, left limit at a, I am mean to say.
Yes.
The problem with this function. First thing, how the function is defined. What is for, where is the problem for this function? What is the, like, where is the breaking kind of is happening, or where is the continuity is not continue with the, at which point? Only
Most
the
likely
problem
zero.
with 0, right?
Yeah, most likely at 0.
Most likely, because rest all r point, the function is like at when x is greater than 0, this is the function, and in this, when x is greater than 0, this function is like we having like a continuous when x is greater than 0. When x is less than 0, this is happening.
Yes.
And when x is equal to 0, value of the function at 0 will be 0 is b.
Yes,
So,
that's a constant. Yeah.
Okay. Now asking for continuous. The continuous means the problem with the, like when is x is greater than 0, it is continuous, like you are able to evaluate the value at each point. The problem is when we use the limit, why we are trying to get limit of the function. What is use of that? See, whenever you have a problem with getting the value, like suppose you have a function defined like let's say x minus a upon x plus a, or maybe x plus x minus x plus a in numerator. So the problem, when you are very close to a, then you are not able to get value.
Yes.
So we will try to get to value. What is the use of limit here? We are trying to get value near about some interval. What not interval, like in, let me say that limit, saying to be limit as, let's say this is a square, again I'm making up as previous one, x square minus a square. Okay, here at a function you are unable to get exact value when you are substituting. What
Yes.
will be at a?
It becomes 0. Yeah.
This function is not defined
Yes.
at a.
Yes.
But still we are using the limit, we can guess that what will be the value at a, like at not a, what will be the near about a. Suppose this is a here, so limit is saying to be we are going to this side or from this side, what give the values when exactly going to be a, like let's say limit as x tending to a. This says that when we are going to a, what's the values, what we are getting, what are the values we are getting, what is the value of the function, where is the value of the function is going when we are going to a.
Yeah.
That's the main. So again here, as here again the problem with 0. So continuity means where we are unable to get exactly value, like in the when x is greater than 0, this portion will work, and when you substitute any real number you are able to get value. When you,
Then how would we do it? That's what I don't get. Because I can understand the
meaning
right
of the
hand
limit,
will
right?
come from the top function x upon 10 plus.
Yeah, x upon 10 a something, whatever is that.
Yes. And the left hand limit will come from the lower one, the sign one.
Lower one, yeah.
But I don't know how to do that.
Okay, so now what is the next term is, this will be as function is defined here a minus h as x upon 10 something, what is that, 10 inverse 2x. So it is 10 inverse 2 a minus h, right? This is the this portion is, now you know L hospital rule, if you apply here.
Yes, sir.
So now the problem is how you will evaluate this limit, right?
Yes, sir.
So what is limit here for this function? Sir have given something formula, some tan inverse form, no?
If I'm not wrong, 10 is x squared. For 10, I know. I think it's x squared. But I don't know about inverse.
In this video, this is of activity 8.1, right?
Only sin x and cos x derivatives given. Tan x related nothing.
Okay. Just one minute.
And sin x by x, limit x tends to 0 equals to 1. That is given.
I think 10x is, I think, 6 squared x, if I'm not wrong.
See, actually, there is this one, x upon tan inverse x, limit x goes to 0 is 1.
Limit x tends to 0, tan x by x equals to 1. No?
Yeah.
Tan x by x
Oh, tan x by x.
is 1. And x cot x equals to 1.
X cot x.
Yeah, x cot x equals to 1.
Okay.
Where do we get this? Where do we get this from? I don't have.
From the Google I
Sir,
got.
tan
Not
inverse
from
x
the
is cot
lecture.
inverse. We can write like that.
Oh, this we haven't been given, so I don't know.
No, cot you make it 1 by tan. That's all.
This
Okay.
one. Tan x by x. So actually, see, L hospital rule can help here. The derivative of this, like what will be the derivative if you want to evaluate this limit? So what will be the limit is, see, this is goes to 0 and tan inverse x. What will be like when you substitute here, just 1 minute, as 0. So we are evaluating limit at 0. Okay, we are evaluating limit here as 0. So a will be 0 here. Okay. So it will be finally minus h upon tan inverse 2 minus 2h. Okay. And limit h goes to 0. Now what will be the limit for this? So I don't know, sir have given or not in this video.
Not given. I also tried for this question. I too didn't get.
Okay.
Only limit x tends to 0, tan x, sin x by x equals to 1, and derivative of sin x and derivative of cos x. These three only given.
Okay, okay. So yeah, actually, when you go with the L hospital rule, also you can apply here. Like,
Derivative of tan x is given, I think, secant square x, and tan 2x, 2 secant square 2x, something it's given.
sorry.
Derivative of tan x is
Yeah.
secant square x. It's given.
For
And derivative of secant square x.
so no. So for tan inverse is
No,
1
tan
upon.
inverse nothing is given. Derivative of tan x and derivative of tan 2x. These both are while doing calculations, it's given.
Okay, okay, okay. So for tan inverse, the derivative is like this. Saying to be derivative is dt of x is. If you search for this, this will come the derivative of the function. And
Sorry, sir. This is tan inverse of x.
This is tan inverse of x. The derivative of tan inverse x. So for 2 here is 2h. So this will be like minus 1 upon it. This will be 1 upon 1 plus 2h whole square. Now position will, this is 2h. So this will be 1 plus 2h whole square, minus 2h is always here. This is minus 2h and this will be 2h. Okay, I'm missing something.
Sir, I've never done actually limits through f a minus h. I don't know how. I've never done this way.
Okay, okay, just one.
Sir, why you have put a equal to 0?
Yeah, a equal to 0. See, so we are trying to get limit at 0 only. Okay.
A minus h is less than 0.
So yeah, I think I'm missing something. That's why it's happening. Actually, this is a formula. Actually, there is a relation also. Limit is given. Tan inverse x upon x is also limit is 1. Again, using the L'Hospital rule. This will be 1 plus x
Minus
square.
2h, derivative of minus 2h will be minus 2. Now, why you take 2h?
It will be minus 2. Oh, okay. I am making here. That's why. Okay, this will be minus 2 here.
Yes.
Yeah. So now when you will substitute here as h goes to 0, it will be 1 upon minus 2. And what's happening here? Okay, b will be. So you got here the limit, left limit. It is the left limit of. Yeah, actually here is needed. Here is what's needed, or you know that tan inverse x upon x as limit x goes to 0, it will be a 1, or you need to know derivative of tan inverse x. That's all, to apply L'Hospital rule. Getting no?
And actually, we don't know these things. That's why we're not able to apply all these.
Okay.
They're not given in the videos, so.
If possible, can you provide these
Yeah, some tan
derivatives, limits
inverse
of some
derivative
trigonometric
and
functions?
The more important ones, because without them, we're not able to solve all of this. We don't know this, so we can't put in a value. We're stuck.
Here should be a hint of derivative or hint of. I don't know in video lecture also. I don't know it's given or not.
Because I also tried this question for almost half an hour. I tried.
Okay, so actually this formula is applied here also. Limit of s x goes to 0, tan inverse x upon x.
That we should give those in that identity related to the trigonometric function.
Actually, in hint of this should be given. Okay.
When I searched
So
in
in
Google,
exam,
it
if you
gave
do the
tan
like
x by x equals to 1 limit of.
Okay.
yeah, that
You
we
wrote
proved
tan
also.
and that is different.
So see, what is the thing is, see, this can be also evaluated using L'Hospital rule. Again, as I'm saying, only needed derivative of tan inverse x.
We are not aware. That's where we struck for solving this problem.
Yeah, actually, see, the thing is, like, if you derivative is taught, like, you have to search what are the derivatives. Like here is in the solve with assignment, I think written in what is the derivative.
It's not there. Tan inverse x is not there.
Oh.
Not there.
Yeah. Some sine cos is given only.
This much only.
Okay. So okay, let's continue. Okay, maybe because of that you people not able to solve. So let's continue with this. So left derivative, I hope you are you getting know what's how I'm evaluating this limit left derivative. The formula is tan inverse derivative of tan inverse is 1 upon 1 plus x square. If you use this one and use L'Hospital rule here for numerator and denominator, as h goes to 0, numerator goes to 0 and this one also goes to 0. So you are able to, this is undeterminate form, and you are able to use L'Hospital rule, and this will come to this form. And if you solve this, this will be the limit 1 upon minus 1 by 2. Now again you have to find the right hand limit. So right hand limit will be, again, as limit h goes to 0, the right hand limit definition is this one. This. So this could be written as h goes to 0. F is as h goes to 0 from positive side. I am missing here. Left side is like saying to be in negative above to the this 0 kind of. That's the mean here. And here will be added a plus, or maybe differently, like let me write the sign, maybe because of sign it will happen. Limit as x goes to a fx, the left limit of this form is limit as h goes to 0 positive f a minus h, or it could be written also limit as h goes to 0 from negative a plus h. This is left limit, and the right limit is limit as h goes to 0 from positive a plus h. This sign says h goes to 0 from positive side. This says h goes to 0 from negative side. Am I audible?
Yes, sir.
What I'm saying here, is it clear? No?
Sir, I've never used this particular formula, so I have no idea actually.
See,
I
whenever
know L'Hopital's rule is that you find the derivative of the numerator and of the denominator and then find the limit. That I know, but I've never used this particular formula. Not come across this.
But left limit you calculate from h tends to 0 minus function f a minus h. But here you are putting a plus h tends to 0 negative.
yeah, so a plus h, but here what it says, this goes to from negative side. This says h goes to from negative side. So it means if you change sign, it will come to this one, right? No, see, this says you are going to a from negative side.
Right.
Here are also saying to be same meaning. You are going to h from positive 0 from positive side, but when you are approaching to this inside, you are going to from negative side. No, see, I am making here. See, this says this sign says h goes to 0 from this side, and you are approaching. Let me say here is a, and this side is a minus h, and this side is a plus h. So this sign says you are approaching to 0 from positive side from this side, and you are inside thing says you are approaching to a from this side, right? Because this portion is positive and this side is happening. This is saying, this is the thing. H approaching to this side, but inside you are approaching to a here from this side. And this sign says 0 is here. Let's say this is a here. So this says you are approaching 0 from this side, and this is suppose a minus h, and this is a plus h. So you are approaching to 0 from this side h is, but inside this is a plus h, as here you are approaching from again as negative, because as here is happening, so again you are approaching this side is negative, this portion is negative. So okay, so yeah, this is a plus h, this is a minus h. Okay, it behaves like this will become positive and this become negative. Again this will be, you are approaching to this side. Oh, okay, this is correct, maybe because of interpretation you are. So let me change it with the h with the minus y. So what it mean that y goes to 0 from positive side, and this is a minus y. This is the same thing is saying, meaning in algebraically it's same meaning, but yeah, it's looking like a different thing.
Yes,
Clear?
Right.
So see, whenever there is talking about the existence of limit, first thing is left hand limit and right hand limit. And this limit saying to be left limit, whenever this is the whole limit is saying, the left limit is writing like this, and right limit is writing like this. So let me step by step, let me write the solution for this function. So for left limit, as here we evaluated, we are when we are less than 0. Let me reach that function first. This one. Oh, so this thing. Oh, okay. I made a mistake here. This says the left as function is defined for less than 0. We evaluated here right hand limit.
Right limit. Yes.
Yeah, I didn't see there. And we have evaluated here right hand limit. Still remain to evaluate left hand limit. So left hand limits again, as definition says, h goes to 0 positive, a minus. So limit h goes to 0. Function from negative side is defined sin ax by, please everyone mute yourself. So this would be sin. Again, our a is 0 here. As 0, we are evaluating at 0. So this will be 0 here. So this is f minus h. Now limit as h goes to 0. F, this is sin a h upon h. Now limit as h tending to 0. This is again from positive side is. So let's make it positive sign. So this is sin minus a upon h. You can do minus, multiply with the minus a in numerator and denominator. And now this portion is as given sin x upon x, limit x as x goes to 0, it gives 1. So this portion goes to 1, and this will be minus a here. Okay. Am I audible?
Yes, sir.
What I did here, is there any mistake or something I'm doing mistake here? Or it is clear, right? Left limit is, I made a mistake there. That is, we evaluated here right hand limit. I mistaken here. I thought maybe that is less than 0, but here is x is greater than 0. So this is right hand limit. Now we have to evaluate left hand limit. So left hand limit is writing to be like this. The next step is 0 minus, the next step is this one. Now left side the function is defined like this, sin minus sin ax, which is a minus h will be here.
Sir, what was our right hand limit value?
Right hand limit is just evaluate here minus 1 by 2.
Minus 1 by 2.
But sir, there we will take a plus h now while calculating right hand limit. We take a minus h.
Yeah, actually that's the we made. Yeah, actually here we made a mistake. Yeah, I thought that side is, I thought this is less than 0. That's why it's happened. Okay. I will again, I will evaluate.
In the last sign.
Sir, can you please just rewrite that one LHN again, please? Okay, so it will be more clear.
Yeah, I will one by one. Let me evaluate this left hand limit, then I will evaluate right hand limit again.
Yes.
So finally we got this left hand limit is minus a. Now let's evaluate right hand limit. So right hand limit is saying to be limit as h goes to 0 positive and f a plus h. So this is, so a is our 0 again. A is our 0 because we are evaluating at 0 here. So 0 means 0 plus h. So limit as h goes to 0 positive, this is fh. Now right side is defined like x upon tan inverse 2x. So this is will be limit as h goes to from positive side h upon tan inverse 2h. So this limit is again as I just now said, tan inverse. You can use directly formula also, or just or you need to know the derivative of tan inverse x. So this limit is saying to be as x goes to 0, this is 1. Or if you know the, let's do by the L'Hospital rule, limit h tending to 0 positive, this will be 1 upon this will be 1 1 upon 1 plus 2h whole square. Now this composition of derivative here is happening, and this will be 2. This is 1 plus 2h whole square upon
Sir, ये जो like tan inverse 2 है ना, L'Hopital rule when you're applying, so can you please explain that one? Tan inverse 2 is how it came like 1
yeah.
plus 2.
So L'Hospital rule says numerator and denominator should like 0 by 0 form should happen.
Yes, sir.
Or
That I understand, but only how did you get the tan inverse 2 as well? That can you please elaborate that?
yeah, so this goes to 0 as h goes to 0, and this portion also goes to 0 because you know tan 0 is 0, right?
Yes, yes.
So that means tan inverse will also give 0 at 0 value.
Yeah. So you took the derivative of the tan inverse 2s and that you found it 1 plus 2s also, right?
This one, yeah. This portion, and now it will go above, and this we obtain. Now this is limit as h tending to 0 positive, and this is 1 plus 4h square upon 2. So if you substitute 0 here, it will give 1 by 2, right?
Sir, into 2 is because of the 2h, right?
This 2 is because of 2h, yeah.
2h.
Because as here we multiplied, like when you
Composite
derivate
function.
this,
Yeah, because
yeah,
of
composite. Yeah, correct. This will come. So left hand limit we obtained here 1 by 2. Right hand limit we obtained a is there or something. A we obtained a is there.
Minus a.
Minus a.
LHS has come minus a, right?
Yeah. So and value of the function is at 0 is here is given b.
Yes.
So f of 0 is equal to b, and all should equal, then it will be continuous, right? Left hand limit and right hand limit and value of the function all should equal, then it will be continuous as the definition of continuity. So that means also b equal to 1 by 2, a equal to also minus a equal to 1 by 2, right? This one should equal to this one, all should equal, then it will be continuous. Value of the function, left hand limit, right hand limit, then it will be continuous. So you got b equal to 1 by 2, a minus a equal to 1 by 2, which is a equal to minus 1 by 2. Now asking for the value a plus b. So what's happening? Is that 0? The numeric answer is 1. Okay. Oh, minus we got or plus? I don't know what's happening here. What we got here, minus a.
Yes.
Okay.
And RHL was, I think 1/2 positive.
Yeah, actually, yeah. Okay. Maybe let's do here again.
Minus a is divided by minus
We can multiply with the plus a, maybe that will give the plus a means we will get the correct answer. Half plus half will be written. Instead of minus a, maybe you will get
Again,
plus.
if you do here L'Hospital rule, it will also work here, because again it is 0 by 0, so it will be cos minus a. This can be evaluated with the L'Hospital rule also, right? This will be minus h. This will be 1. Limit as s goes to 0 positive. So yeah, this is limit is minus a we are getting. Okay. So, and here we are getting 1/2. Okay, this is correct.
Earlier we were getting minus 1/2. Earlier when
but we made mistake because of that. Because we thought that is a left limit, but that is a right limit we did it there. So it will be not 1/2, it will come to 1/2, not 1 minus 1/2 will come. Okay. Okay, whatever, I maybe numerically we did mistake, or I don't know. I will check it. I will check once. Okay. So okay, that's the whatever. This is the process to get left hand limit, right hand limit, and this will be the value. This is minus a is equal to minus 1/2. So a plus b will be 1/2 minus 1/2, which is 0.
0, but I think the answer is 1. Yeah.
Answer is 1 is there. Okay. This is okay. I will check once. Maybe I will check it. Is that any answer?
Sir, when we're checking the left hand limit, we say limit as h tends to 0 plus. So why do we do plus even when it's left
Plus
hand?
means says direction. Don't worry with this is direction. Like we are approaching to 0 from positive side. Suppose this is real line. Plus this we are approaching to 0 from this side. Plus side, from plus side.
But I always thought left hand limit is always from the left.
Yeah, so left hand limit is, if you are confusing, the left hand limit is writing to be limit h tending to 0 from positive side f a minus h, and right hand limit is
Limit h
tending to 0 again from positive side,
but f a plus h.
A plus h. If you are confusing with this, just assume this. This is the best way to saying. You are approaching to 0 from positive side,
Yeah.
and this is left
Negative.
limit, and this is
Yeah.
right. Okay.
It's always approaching to 0 from the positive side.
Yeah, it is always approaching to 0 from positive side.
Okay.
So yeah, maybe I made numerically mistake here, or maybe answer is also wrong. I will check and I will post it in discourse, whatever the correct is that. I will write the whole process, whatever here, and I will post the answer in discourse. Okay.
Thank you, sir.
Yeah.
Sir, in forum also, because I think we qualify.
Yeah. In forum also I will post. Yeah.
Yeah, because we don't have discourse.
Yeah. So, okay. So let's move on to the next. Divya is done. Okay.
I just asked him.
Yeah. Prasant.
Yes, sir.
Yeah.
8.3.3.
8.3. Which question number?
3.
3. Okay. So your function is defined like this: x mod x. Which of the following option is as to f is not differentiable at any point of R? F is differentiable. F prime will be this one. All is written here. So What's the problem here?
So I'm choosing the last option. F is not differentiable at 0, but they are saying that it is differentiable. But when we see the graph of differentiation, it shows it is not defined at 0, x mod x.
No, as
The graph,
fx.
the graph of differentiation of x mod x is not defined at 0, right?
No, it will be defined. It will be defined. See, this can be written as x square when x is greater than 0 or greater or equal to 0, and minus x square when x is less than 0, right? Right? Because as mod x is see, this can be, or maybe let's make it as it is. This is x time when x, now let's write this one, when x is greater than 0, this is x as it is, and when x is less than 0, it will be minus x. Now it is x square minus x square when x is greater or equal to 0, and when x is less than 0. This is your function. Now what will be the f prime? So see, when x is greater or equal to 0, you can make it that, because there is no issue, this is a quadratic polynomial from this side, so just write the derivative of this form, because there is no issue. And for left side, just write the derivative for this side. But now you have to check at 0. Still it's remain to check 0. We just quickly wrote here, but you have to check, is this function is differentiable at 0 or not. You have to check once.
That is the confusion, sir.
Yeah, so for that you just write the definition of differentiability, limit definition. H tending to 0, f a plus h minus f of a upon h. So you want to check at 0, so a will be 0 here. Now let's do for the this says to be limit for both sides, so you have to make it separate, left and right limit. Now this is the definition for derivative. Now you have to change it in left limit and right limit. So the left limit is limit h tending to 0 plus f. Let's make it limit of this portion. So it will be minus g at 0. We are checking left. This is left limit. So this will be minus h. Again at 0, this is 0. So this will be minus h. Value of the function upon minus h. Right? So this is 0 here. So minus f of minus h is this side is coming, so it will be minus 2x square. So this is, again it will not affect here. So this will be minus 2x square. X square means it will be minus h square. Minus value at the function is 0 upon h. This is limit h tending to 0 positive. Now it is 0 you got, because it will be cancelled out here. Means h square minus h square upon h will come, and this gives the limit 0. Now check for right derivative, means right hand limit for this function. So limit h tending to 0, f of this is h is there, so it will be h upon value of the function upon h. So again, if you check, you will get this limit as also 0. That means this limit is exit and equal to 0. So this says the function is differentiable at 0 and derivative is equal to 0. So this is fine, right? Because if you put here 0, you will get the derivative 0. Getting, no?
Yeah, sir, I got this. My confusion started from Desmos, sir. When I am plotting this derivative function in Desmos, they are showing this derivative function is not defined at 0. So I got confused.
So see, this is derivative. No, derivative function is not defined at 0, but you are getting derivative at 0 is 0, right? So how it says it is not defined? Because you are getting derivative as 0 is 0.
Yeah, I got this point, sir. But when we are plotting this f prime x in Desmos, this 2
See, in
they
Desmos, it is difficult to plot this one because this is a step function. In Desmos, you are not able to plot this step function.
I'm not plotting this. I'm plotting the derivative of fx, x mod x.
X mod x.
Yeah.
So how you are plotting the derivative of this? Okay, let me. Is there any way to plot this, the derivative of this function?
Yes. So if you
What is that?
so you just go in these options. These
Here.
dashes are coming now. These 4 lines are coming. Upper. Yeah, in you go calculus functions.
Oh. Calculus derivative.
Yeah, derivative.
Okay, so
Yes.
for that I have to first write here.
Yes.
Okay.
Then
Derivative.
yes. Open graph.
Yeah, it's
Click on this.
yeah, it's okay. This
Here
is
you in fx you put that function x mod x in first.
okay. Here.
It will automatically plot the graph of its derivative also.
Okay.
Here, if you see this violet line at 0.
So actually, see this.
Sir, you move cursor on that violet line, graph of derivative function. Then at 0 it goes
No, it's
undefined.
defined. So see, this says that when you are clicking, you are able to get value. That's the meaning. See, when you are clicking here, you are not able to get value. But when you are clicking at 0, it gives the value. That means you are able to get value at 0. Oh, here is undefined.
But it's
Yes,
only
sir.
for mod X it is defined.
Sorry?
Is it the case that it is only defined for mod X?
It's defined for
Somewhere it is showing undefined.
okay. Here is okay. Writing for undefined. No, but
Yes,
this is
sir.
not.
This is the thing which when I got confused.
No, it is properly. See, this function is not a kind of rational kind of, or maybe like one upon kind of. It is like simply you are able, when you're substituting, you are able to get value. So I don't think,
Why
I don't know.
that
It's
is showing over there, sir? I'm not getting.
but yeah, but see, algebraically you are able to see it is correct. It is what's happening. We did here.
Yeah. But can we go like what is the meaning of that 0 undefined in best mode?
No, I also don't know why it says at 0. It's maybe for I don't know for which purpose it says. I don't know what's the meaning.
Actually, it's the same thing we are getting in 8.2.5 x raised to the power 1 by 3. Same confusion is there.
Yeah, for 1 by 3 there is problem. X to the power 1 by 3. This is not differentiable at 0. So that's why it says this is not differentiable at 0. So you are unable to get value at 0 of the derivative. Here is not such case.
Yeah, so that's why I choose this last option, sir, and got around as per the answers available in this portal.
But the case is this is differentiable. Algebraically, we are able to do. I don't know why it says this. Yeah.
Yeah.
Okay.
Okay. So just 8.3.9.
8.3. Question number 9.
9. Yes.
Here, okay. For which option? What is the doubt here?
So doubt is if fg is differentiable, then both f and g are differentiable. So from the the rules of as told in the lecture, if f and g are differentiable, then fg is also differentiable. Multiplication rule, right? Why this option are not true?
So this is reverse part, right? See, the statement says if f and g is differentiable, then fg is differentiable. But this option says fg is differentiable, then f and g is differentiable. See, this is the reverse part saying which cannot be always. This is always f and g is differentiable implies this one. But this may or may not be also.
Okay, I got one. I got confused from the sentence. Okay.
Oh.
Thank you.
So, okay, I don't know, because of this internet issue, I lost many participants. So, okay, so when you have, I don't know, Prasant is done. I think Dibya is also done. Or if you had,
Yes.
yeah.
I have done.
So now, okay, let me see. Rahul.
Yes, sir. I have a doubt from activity 8.4.
8.4.
Question number 6. So let me tell you first my approach. So suppose we have one given function and we want to find any tangent or a derivative. We usually derivate or find the differentiation, find the tangent. So for going back to
slope of the function.
yeah, for going back, I don't know how to solve this, so I just have some, you can say, a brief knowledge of integration. So I integrate that y equal to 3x plus 2 and got one equation and put 1 in there to that and got the answer. Is that right approach?
Okay.
So from differentiation, I want to go back to the function. That's why I integrate the function. I got some equation, put the x equal to 1, got the answer 5, luckily. But I don't know, is there a right approach or how to solve this?
Yeah, but when you okay, when you integrated, okay, you will get a constant and you substituted their value and also get the constant value.
So for me, integration was 3x square plus 2x. I just put 1. So 3 plus 2 got 5 and the answer is 5, luckily.
No. So still when you integrate it, it will be 3x square plus 2x plus
2x.
c will come, some constant integration constant.
Yeah.
So how
But
you are
I ignored that c.
No. So you cannot ignore this one.
So how to solve this one?
Yeah. So for this, see, this is that tangent. You have to find the tangent of tangent equation of this line and compare with this one. So suppose, see, this is the tangent line at the point 1 and f1.
fx1.
So let's write the formula for what is the tangent. This is y is equal to f prime 1 x. Sorry, what is the formula? Plus f1, right? This is formula, yeah.
Yeah.
This is formula, or at any point. This is for any point. Now at 1 it is asking, so let's compare at 1. So this will be f prime 1 x plus f1. This is the equation of tangent, and this says this is exactly equal to y is equal to
But so that is x plus a, right? F dash a x plus a.
So here is one. So this is for general point a. This is general a, but this formula is at a at 1. Sorry, this is at 1. Tangent equation at 1.
Okay.
And in the information says this is the equation, and you just wrote as you know the formula, this one. Now if you compare, see, these two are equal. This is the formula you wrote, and this is given. Now just compare.
You want to say f dash 1 equal to 3 and f dash 1 equal to 2. Yeah.
This is happening.
But the answer is 5, sir.
Yeah. Just 1 minute. Maybe I am doing something mistake. Okay, so suppose the tangent of the curve given by this one, is given by this equation. What is the value of the function at 1? Okay. Okay, just 1 minute. Tangent equation is, I am making some wrongness. That's why this is not.
Sir,
this
hello
is
sir.
x
Can we do?
This is the formula. This is, I think, this is the formula. That's why f prime a x minus a plus f of a. This is the formula, right? This is the equation of tangent. You can see it here. This is the best thing. This is the use of, you can say, this is the formula. A we are using, that's why it's happening. So let's do here. Now it's compare with the 1.
Now you get 3x plus, no, 3x minus 3.
So this will be f prime 1 x minus f prime 1 plus f1. Now just compare. F prime 1 will be 3 and f prime minus f prime plus this one will be 2.
Okay.
Now you have this.
That goes 3. Okay, I got it. 3 plus 2, 5. Yeah.
Minus it. Now f1 will go. This is the formula. That's we made a mistake.
Okay.
Sir.
Yeah.
Hello.
Yeah.
Can we think in another way, like just the a point means one is lying on the tangent, means tangent is touching the curve, na? So at any point, at a common point, both these curves and tangent are touching. So one could be the common point for tangent and this curve. So we can calculate the value for tangent. I mean the curve at one point by putting the value x equal to 1 in tangent function.
No. If you can speak in your Hindi language also. No, I didn't get your question. What is? Can you repeat again?
So he's saying, so equation of function and the equation of tangent must be equal at point A because they are intersecting.
Not intersecting, touching. You can say.
Yeah, yeah, you can say that.
Yeah,
But
it's touching.
x equal to 1, they are touching. So their values will be equal. So you can put y equal to 3 x at. You can put x equal to 1 in the tangent form, tangent equation. So you will
X
get
is equal to
simple
1 in this tangent equation.
y equal to 3x plus c, yeah, in tangent
Yes.
equation. because they are you can say touching each other, so their value must be
Yeah,
equal
one
at
thing also,
x
yeah,
equal to.
correct. This is also, yeah, because it is touches at that point.
Yeah, yeah.
So directly if you substitute 1 also, it will give 5, and
Then
that is
you will
correct
get
also.
5.
Yeah, correct. Correct.
Yeah. That seems much simpler.
Yeah, that seems much simpler. Yeah, that's the meaning also for using of tangent.
Yeah.
Anyone else?
So, sir, that about that x mod x, in the lecture 8.2, like sir is telling at the minute 19.09 minutes, mod x is not differentiable at 0.
Mod x is not differentiable, yeah.
X mod x is differentiable, right?
Mod x is not differentiable, but x mod x can be differentiable. Mod x is not differentiable, but x mod x is differentiable at 0 also. And this is not differentiable at 0 only. Rest are it can be different. It is differentiable. But this is x mod x is also differentiable at 0. And because of we just, that's the we verified. See, we directly put here the derivative, but we have to verify at 0. So that's the, I took left hand limit and right hand limit and verified that, yeah, derivative of mod x, x mod x at 0 will be 0, and we got 0 also. So we are able to get value at 0. So that means it says, that means it means 0 means we are able to get limit, this derivative form.
Right.
So that means function is differentiable at 0, and we are able to get value of derivative is at 0 is 0.
So mod x is not differentiable at 0, but x mod x is.
X mod x is differentiable, yeah.
Okay.
Anyone else have doubt, or we can close session also? I know I lost so many participants because of this internet issue. Now I will try to fix it from next day. Now it is also better. That time maybe because of heavy, that is the internet, I don't know. So anyone have doubt, or we can end the session also?
No, sir.
No, sir.
Okay. Okay, thank you so much for joining. Have
Thank
a
you, sir.
yeah, good night.
Thank you very much, sir. Thank you very much.
Thank you, sir.
Thank you so much.
Thank you, sir.